again, very, very diverse backgrounds that we use. So you put all that together and get selected for the program. An interesting process, by the way. You start off, of course, it's a volunteer program. You can actually go online, download the application form from the Johnson Space Center, basically fill in your resume, if you will, and then they start to go through a winnowing process. The year that I was selected, we had about 10,000 applicants to select 19 people. So it does narrow down. In fact, I like to point that out, particularly to students, because although it is a very restricted process, you actually have a better, percentage-wise, a better chance of getting selected from the astronaut program than you becoming a professional. So you go through a week-long series of interviews and exams, physical exams, psychological exam, and then finally you finish up sometime during the week. You sit down and interview. It hasn't changed any since the early days of the program. It appears more like an inquisition as opposed to an interview, because you have people sitting around you in a round table. They put you on a chair kind of in the middle. The only thing that's missing is the spotlight. And then they ask you one question, starting with high school. Tell us about yourself. You have however long it takes you to tell you your background. Of course, what you're trying to do during that process is give the interviewing panel an idea of what you've done in your career that may make you a good candidate for the astronaut program.
Here, this is all.
So when do you get to the nitrogen?
It's actually right here at the top. This whole container is almost filled, so you can see it pour out.
But that's not. But this is water vapor.
This is water vapor out here.
But
no, I'm sorry. This is liquid water. This is nitrogen.
Oh, so you are pouring nitrogen onto the carpet, and nobody's stopping you.
That's no. I got in trouble a couple times.
So what does that do to the carpet?
No,
not much.
It's just cold. Yeah, it's very cold. All right. So it's cold. So right. So what happens when I stick this into?
Shrinkage. It's gonna pop.
Let's see.
Wow.
They crack the plastic.
It must be special silicone.
No, these are regular balloons, actually.
I would totally hire you for a birthday party. You froze the air.
I never heard that. Okay, so now I'm going to take this out in a second. I want you to look at the bottom. By the way, where did the air go?
Solidified. Change state of matter.
To what? Did it solidify or did it
Liquefy.
Okay. So let's look at the bottom. I'm going to hold this up. And you're going to see in the bottom. See the liquid? So that's liquid air that's in there, and it takes up less space. And actually, we can reduce the size by 700 times by turning the air from a gas into a liquid. So you can fit a huge amount of air into a small container, break it up, bring it up to the space station.
So that's what oxygen is.
That's right. And take it back to the liquid phase, and then you can breathe. And guess what? When we do the electrolysis, one of the things that they do on station and also on the space shuttle is when they mix inside of fuel cells, and that gives off electricity. So it powers electrical equipment on board. And is also giving them, that's right, and gives them drinking water. Here's the deal. The space shuttle, the space station, they need to have oxygen in space. So the question is, well, first of all, how do we get this pure oxygen? And then also, the oxygen used for for powering things on board the space station that we'll talk about in a second. So I've got a goal for you. And the goal is you're going to make, we're going to do electrolysis of water. And we're going to see who can most efficiently get the products of electrolysis of water. And I've got all the supplies here. Okay, does anybody know what electrolysis of water is? Yes. We want to separate oxygen and hydrogen. You're going to have to figure out in the test tubes which tube is hydrogen and which tube is oxygen. and why it is the case. I've got whiteboards here. I want you to write that down. So which one will be hydrogen, which one will be oxygen? We'll do that. And then, there's one other thing. I can't remember. All right. So what I want you to do is one person with your be a materials engineer, come over and get a box of supplies. And then I'm going to show you how to just prepare the electrodes for the electrolysis of water. And fold them. Each one separately, yeah. And fold them. You're just going to fold them over again and again and again. Lengthwise, yeah, the longest way. And then doesn't matter until you get 2 of these. Then in a cup of water, you're going to get a cup of water. You're going to need a couple of cups. Because you'll probably need one just for some extra water. I'm going to put some water in here. Fill this up. Put the electrode in. Okay. And then finger the full set. Now, here's the question that I have. We're going to do electrolysis. Now, I want to know, you've got water and some other stuff over here. Does pure water conduct electricity? Why? Okay, so here's what I want you to do. I've got this water. I also have some salt over here. I have in your box a scale. Here's a scale. And I want everybody to do a different experiment. And everybody decide on whether you're going to do no salt, a little salt, a lot of salt, and you're going to find out how long it takes to collect a test tube of either oxygen or hydrogen, whichever gets there first. Okay? Of course, we've got the first thing of trying to determine which test tube will have the oxygen, which test tube will have the hydrogen. All right? And then the second part of this is determining how much or no salt you're going to put into your mixture. Okay? Now, can I ask you this? Should you, when you do this, should you fill up the test tube first with the water and then put it into a salt solution, or should you mix it up and then put it in to the test tube? Okay? I'm not going to answer that question. I'm going to let you answer that. I'm going to just ask the question. Okay? So I'm going to leave the rest of it set up here. Of course, you put a battery on this. I'll set it up and show you how the battery should be set up. So at this point, you've got your goal. Yeah, you got your goal, what you're going to do, and then we're going to test it with a little candle flame to find out what happens.
Way to do it.
I don't know, that she's using a different time.
Your zoning. But regular water from here. Are we going to
I zeroed it.
It's not zero.
It's not anymore,
Zero.
but it has to be zero.
Without the cap, it should be zero, right?
Yeah, you can do it that way.
Oh, okay.
But then you have to find out.
Siri?
Was that the oxygen?
1.3 grams. With this, 5.5.
You want to fill it all the way to the top?
Hold on. Stop that. Okay, how much?
Well, that's what we were referring technically.
Did we take the time when this be
No,
Yeah,
we didn't.
we might want to take it like right now. It was maybe about a minute ago.
That was good.
Okay, so are there two ways that we can determine what's in the tube? So the one way is that we can look at the terminal. If it's positive, it's collecting the oxygen. If it's negative, it's collecting the hydrogen. Or we can visually inspect the tube, and whichever tube is filled first, essentially, in other words, it'll be almost all the way filled with one gas. The other tube will be about halfway filled. So that means the hydrogen is the full tube, and the half full one is the oxygen. Okay? And then, as they suggested, the way to test that is then take your tube and hold it over the candle flame, and it will pop. Now, results. So, first of all, tell me what you did. What happened? Sort of give me your observation.